Welcome to this video, great to have you on board. My name is Maximilian, and in this video I want to dive into a super important topic in JavaScript development: handling asynchronous operations with callbacks, promises, RxJs, or async await. When should we use which tool and how do they actually differ? We'll take a closer look at these questions in this video. So, handling asynchronous operations is a super important task in JavaScript. You probably won't write or create any application which doesn't use some asynchronous operation. Now, JavaScript offers you different ways of handling asynchronous operations because by default, JavaScript of course is synchronous, executes one line of code after the other, and therefore you need certain approaches or tools to handle these asynchronous cases. I actually did write an article about that too, so if you're more like a reading guy or you want to read after watching this video, check out this article where I will dive into the main or the major approaches offered by JavaScript and outline how they work and how they differ and when you might want to choose which. But of course, I'm also going to take a look at this question in this article. So let's do this right now. For that, I created 4 examples, and you can find links in the video description. And I want to start with callbacks, the oldest or simplest way of handling asynchronous code in JavaScript. Now here on the left you see my JavaScript code, on the right you see a button. Let's click the button first to see what it does. If you click it, it's first checking authentication, fetching a user, and then displaying the username, Max, my name. Okay, so what's happening here? Well, in the code I first of all get access to the button and then to the div where I want to render that. Username, nothing asynchronous thus far. Then I have 3 functions here. I'm using arrow functions, a ES6 feature, but in the end it's just functions. The first one is just a helper function which will render the text, the username basically, but I could use it for any text once I got it. So here I'm just accessing text content of the div I fetched and output some text. Then check off is just a faking asynchronous function where I use a timeout over 2 seconds to then do something to which I'll come back. And I also call set text to display checking off here instead of the username whilst I am checking the off. Now, of course, in a real application, you would probably reach out to a server here, for example, to verify if some token is valid, if the user is logged in. And here I'm just faking this, that we have to wait for the actual response, whether it is true or false. I'm doing this with set timeout as mentioned. The same for fetch user. Here I'm also updating the text, and then I use a timeout to fake the fetching of a user. Now you probably already see this CB thing here, which I call inside the timeout. So once the timer finished. And that is the argument these arrow functions receive here. So CB is just the argument passed to the function. That leads us to the question, what is the argument and who's calling these functions? The argument obviously is a function itself because we execute it like a function, passing an argument to the function then. In this case, we're executing CB and pass true. Here we execute CB and pass a JavaScript object. And the one calling CB is inside here, the event listener on the button. Here I call check off. Then I pass a function, that's just another arrow function here, to check off. And that's super important. I'm passing an anonymous function here to check off. And remember, check off did require a function, CB called here. You can of course rename the argument here. So I'm passing a function to check off, which check off will execute once the timer completed. And it will then pass true to that function it got as an argument. So basically, to that function, off, the argument of that anonymous function, will be true in the end because I passed true to the function passed to check off. That's this anonymous function. So this anonymous function gets called whenever this timer and check off is done. And then we pass true as an argument to that function, so off will be true. As a next step, I do check that. And this is already asynchronous here. This code inside this anonymous function will only run once the timer completed. Because what we do here is we tell JavaScript, hey, please don't stop execution. It wouldn't do that anyways. But be aware that whenever the timer is done, you should execute this function here, this anonymous function, which then in turn executes callback true. That is what we tell JavaScript. Be aware that you have to do this in the future once the timer is done. So this code here only runs once it is done, once the timer completed. Then we checked off the value the timer gave us. And then we execute another function, fetch user. So that's this function here, fetch user. And it works in the same way. We pass an anonymous function to fetch user, this arrow function here, where we expect to get a user then. And this anonymous function is now executed inside the timer of fetch user. After 2 seconds, we execute what fetch user received, our anonymous function. We execute it and pass an object to that function. So user here will be that JavaScript object. Well, and then we simply call set text in there. So checkoff is executed, and the anonymous function for checkoff will run after 2 seconds. So after this timer of checkoff. And then inside of that code, which runs after 2 seconds, we reach out to another function which uses a timer, so that after a total of 4 seconds, we will run this code, 2 seconds from checkoff and 2 seconds from inside here, from fetch user timer. And this is what happens here. We click fetch user, checking off for 2 seconds, fetching the user for 2 seconds, and then seeing the user. These are callbacks, and on a first look, there's nothing wrong with that, right? We use callbacks, looks like a good solution to that. We tell JavaScript to do something at a later point of time so that it can continue executing the rest of the code and then just execute that code it remembered once it needs to be executed. The issue is something we can already see here. We're nesting all these callbacks. Imagine we would not output the text inside fetch user, but then do something else. Call some server-side function which transforms the user. Then we would have transform user. This function doesn't exist here, but we could have that. And there we would pass another callback function where we get the transformed user back, which we can then handle in there. So handle transformed user. And you can already see where this is leading to. We got a lot of nesting going on, and this is actually called Callback Hell, because you add more and more callbacks, and it gets super hard to manage and to understand. Error handling becomes a pain, because if you handle an error inside a callback, you probably want to call another callback, and that's no fun. Hence, JavaScript gave us a solution to that with ES6, or already earlier, if you used some third-party libraries, promises. The general setup here is the same. I still get access to the button and to the div, and as you can see, if I click this, it works the same as before, checking off, fetching user, outputting the username. But the code inside check off and fetch user changed. Here, I'm not calling some callback anymore. You can see these functions don't receive an argument anymore. Instead, I'm returning a new promise. And promises are a construct, a class introduced by ES6. Promises, as their name suggests, are classes which promise a certain value in the future. So they're also a tool for handling asynchronous code. In this case here, the promise, or always a promise if you create one on your own. And as a side note, oftentimes you don't create promises on your own, but you use some third-party library like RxJs for making HTTP requests, which will automatically give you a promise. But here we're creating it on our own. We create it on your own by calling new promise, and to the promise constructor, I pass an anonymous function, which gets 2 arguments, resolve and reject. These are actual functions you can execute inside that anonymous function here. And here I'm then again creating a counter, a timer inside my promise anonymous function. And after the 2 seconds, I call the resolve function here, which will basically inform JavaScript this promise is done, we got a value. And this is something you need to do in the promise in the end, because you do promise a value. You could also call reject to throw an error, but here I'm just using resolve. And then we resolve true, and the same for the new user. Here I resolve my JavaScript object. Now, on first look, you might say, well, that doesn't look that much easier than for callbacks. Yeah, but again, keep in mind, oftentimes you're not the one creating these promises. Oftentimes you will use some library which already gives you promises. The interesting part comes if we have a look at how we can use promises down here. This is much cleaner code. We listen to the click, and then inside this click handler, we call check off. And then we don't pass any function to check off, which gets nested, but we simply call then chained to the check off call. Now then takes an anonymous function where we handle this value we get back from the promise, so true in the case of check off. That gets stored here, that gets automatically passed as an argument. And then I simply return a new function call, return fetch user, calling that second function, which also returns a promise, keep that in mind. Now here we're returning this, and in the past we would then kind of like either use a callback in there, or with promises you could think you'd now call then there too. But the cool thing is if you return a promise inside a then block, you can simply chain another then block after the first one. So you never have this deep nesting of callbacks or anything like that. You simply have then after then after then until you're done. Like here, that's the last then block. We then get a user, which we output. So if you got deeper layers of nesting, promises are great because you never get the same behavior there. You just have then after then after then. And it's also easier to handle errors. You can read more about that in the article I mentioned at the beginning of the video. So that's promises, already a great tool. Do we need more? Well, there is another construct named RxJs, which gives us observables. Now, RxJs Observables are not a native JavaScript features like promises are, but they are made available through a third-party library. RxJs is the name of that library. Same code as before here when it comes to getting access to the DOM, but then check off and fetch user do something else, something different. They return an observable basically. It looks a bit similar to the promise. We create something here and then we pass a function to what we created, and in there we call set timeout, and after 2 seconds we call, in this case, the observer and the next function. But that's kind of like resolve for the promise. We basically emit a new value. A core distinction between promises and observables is that promises handle one value. You send a HTTP request, you get a response, you resolve your promise, you're done. For observables, that's different. You can handle streams of data there. You can wrap an observable around a click listener to listen to every new click and emit a new value on every new click. That's not possible like this with promises. Here again, we're just setting up our simple observables, and then down there you see this wrapping around an event. In the past, we used add event listener on the button. Here, I'm using an observable method to create a new observable from an event on the button, the click event. And then here we're using something the RxJs library offers, so-called operators. And there are loads of operators made available. I actually do have a RxJs series on this channel in case you want to dive deeper. These operators are great though, because you simply chain them after each other. So like the then calls for a promise. Here, in this case, switch map basically handles the first asynchronous value, which comes from this click event. So we get the click event, and then we call check off. And that's just a short ES6 arrow function. Keep in mind that this in the end returns check off. That's important to know. So we return whatever check off gives us, and check off just gives us another observable. We call another switch map, which will just take the last observable, so the one returned by check off, and maps it into a new one. In this case, the one we get from fetch user. So we use the value from check off and return a new observable. And in the end, and that is something you have to do on every observable, you have to subscribe once your chain ends. So what you want to do after you went through all your observables. In this case, we subscribe, we know that we will get a user in the end. That's just what gets returned by fetch user, and we can output it here. And hence, if we click this, we get the same behavior as before, but now using RxJs. And RxJs can be a little bit more complicated to learn, also due to the many operators it offers. But being able to handle streams of data, again, not that easy with promises. And having all these operators, which can be complicated, I'll give you that, but which also offer you so much possibilities and opportunities to work with your data streams. These are two arguments really in strong favor of RxJS, and personally, I can only recommend trying out RxJS Observables and working with them. They can really enhance your projects quite a lot. On the other hand, it's of course not the perfect solution for every project. If you got very simple asynchronous operations, you don't need to handle data streams and you don't need all these operators. It doesn't add that much value to your app to bring in the RxJS library, which of course will also increase your final bundle size. That's something you have to keep in mind. It's not a native JavaScript feature, so it will add to your bundle size. But if you are working with data streams, or if you do see that these operators add some benefits, definitely check out Observables. So Observables are awesome and promises are a good alternative. What else do we have then? Async await. That's a new feature coming with JavaScript ES8. Still, you can already use it with some transpilers like Babel, for example, and adding some polyfills probably. Here we got the same starting setup and then we return promises, just like in the promises example. The code up here for check off and fetch user is exactly identical because async await just uses promises behind the scenes. That's super important to keep in mind. Async await uses promises. It's not yet another alternative, it uses promises. It gives you a different way of handling these promises once they resolve or reject though. Let's scroll down. Here we have our event listener, and if you check this code, it looks very synchronous, doesn't it? We create a constant, we initialize a user variable with an if check where we set the user variable, and then we set text. This looks like synchronous code, one command running after the other. There is no nesting with callbacks, no then calls, and no subscribe calls from RxJS. There are two important keywords though, async and await. Async has to go in front of your function definition. So here we're defining and passing an asynchronous function, an anonymous function, just a normal anonymous arrow function, and we turn it into an asynchronous function by adding the async keyword in front of it. Now to JavaScript, this will signal that everything inside that function may use the await keyword to pause the JavaScript execution, you could say. So that is what await does. Here we assign a constant and we tell JavaScript the value of the constant should be what checkoff resolves to, what the promise returned by checkoff resolves to. Because keep in mind, I said it a few seconds ago, async await uses promises and only works with promises. Checkoff returns a promise and we can then wait for this promise to resolve, and JavaScript will basically wait, or behind the scenes use then again, wait for checkoff to resolve and then store it here. And only then it will move on and execute the next code line. That is why you can only use that in especially marked functions, because the default behavior of JavaScript is a different one. Each line gets executed after the first one and it doesn't wait for some async operation to finish. Now here in such async functions, it kind of does. And we signal it to wait with await. The same here for fetch user. We tell JavaScript, don't execute this line, set text, before this operation here is done, and we stored the resolved user in the user variable here. That is why if I click this button, we see the same behavior as before, but now without calling then or using callbacks or subscribe. Async await therefore is a great tool to write easy to understand code, which looks like synchronous code, and therefore definitely a tool you should keep in mind and you should use when working with promises and when working with chains of promises where you have a lot of then blocks after each other maybe. Because you can write very clean code with async await. Just be aware it's always the combination of async and await, you can only wait in async functions. Now again, check out this article I referenced at the start of the video if you want to learn more. I hope this video gave you a good overview over these 4 tools for handling asynchronous operations. In the video description, you can find more links with more resources to dive into these different tools and learn more about that if you want to do that. I hope you enjoyed the video. See you in future videos hopefully. Bye.